Have you ever wondered if living forever is possible? The idea of immortality, a concept once confined to myths and legends, is now being explored by scientists and researchers across the globe. Today, we embark on a thrilling journey into the world of groundbreaking research and explore 5 fascinating ways humans might achieve immortality. Buckle up, because this is going to be a thought-provoking and fast-paced exploration into the future of humanity. Our journey begins deep within the code of life itself, our DNA. Scientists have long known that aging is, at its core, a genetic process. As we age, our cells accumulate damage to their DNA, leading to a decline in their function and ultimately, death. But what if we could rewrite that code, eliminating the biological limits programmed into our very existence? Enter the world of genetic engineering. Imagine a future where scientists can identify the genes responsible for aging and manipulate them to slow down, halt, or even reverse the process. This isn't just science fiction. Researchers have already made significant strides in extending the lifespan of simple organisms like worms and flies through genetic modifications. One promising area of research focuses on telomeres, the protective caps at the ends of our chromosomes. Like the plastic tips on shoelaces, telomeres prevent our DNA from fraying and unraveling with each cell division. However, telomeres shorten over time, eventually leading to cellular aging and death. Scientists believe that by manipulating enzymes called telomerases, which can lengthen telomeres, we might be able to slow down or even reverse the aging clock. Imagine a future where gene therapy allows us to receive targeted treatments that repair damaged DNA, eliminate harmful mutations, and keep our cells functioning optimally for decades, even centuries longer than currently possible. This could fundamentally change our understanding of human lifespan, ushering in an era where living to 150 or even 200 years old becomes the new norm. But the ethical implications of such profound genetic manipulation are immense. Would access to these life-extending treatments be available to everyone, or would it create a society further divided by wealth and privilege? Would extending lifespan lead to overpopulation and strain our planet's resources? These are complex questions that society must grapple with as we venture further into the realm of genetic immortality. Let's shift our focus from the physical body to the essence of what makes us human, our consciousness. What if, instead of trying to preserve our bodies indefinitely, we could transfer our minds, our memories, thoughts, and experiences into a digital realm, free from the constraints of biology? This is the central premise of mind uploading, a concept that has captured the imaginations of futurists and science fiction writers for decades. The idea is to create a digital replica of your brain, a complex simulation that captures the intricate network of neurons and synapses that make you, you. This digital consciousness could then be uploaded to a powerful computer, a virtual world, or even a synthetic body, achieving a form of digital immortality. While still in its early stages, research into brain-computer interfaces and whole-brain emulation is steadily advancing. Scientists are developing increasingly sophisticated ways to map the brain's neural connections and decode the electrical signals that govern our thoughts and actions. Imagine a future where you could wear a device that records your memories and experiences, building a comprehensive digital archive of your life. This digital archive could then be used to create a virtual avatar that looks, speaks, and thinks just like you. Your loved ones could interact with this digital representation of you long after your physical body is gone, preserving your legacy in a way never before imagined. But mind uploading raises profound philosophical questions about the nature of consciousness, identity, and what it truly means to be human. Would a digital copy of your mind truly be you, or simply a sophisticated imitation? What would happen to the original you once the transfer is complete? These questions delve into the very core of our existence and challenge us to redefine what it means to live and die in the digital age. Imagine a world where microscopic machines patrol your body, constantly repairing damage, fighting disease, and keeping your cells in pristine condition. This is the promise of nanotechnology, a field with the potential to revolutionize medicine and redefine the limits of human lifespan. Nanobots, tiny robots smaller than the width of a human hair, could one day be deployed within our bodies to carry out intricate repairs at the cellular level. These microscopic surgeons could identify and destroy cancerous cells, clear out artery-clogging plaque, and even reverse the damage caused by aging. Imagine a world where you could receive a simple injection of nanobots programmed to seek and destroy the specific biological markers of aging. These nanobots could work tirelessly 24/7 to keep your body in a perpetual state of youthfulness, essentially halting the aging process at the cellular level. The potential applications of nanotechnology in medicine are vast and awe-inspiring. Scientists envision a future where nanobots deliver targeted drug therapies, repair damaged organs, and even enhance our cognitive abilities. With nanotechnology, the human body could become a self-repairing, self-upgrading machine, capable of maintaining its optimal state indefinitely. However, the development of nanotechnology also raises concerns about potential risks and unintended consequences. What safeguards would be put in place to prevent nanobots from malfunctioning or being used for malicious purposes? Could we control these microscopic machines once they are released into our bodies, or would they have the potential to run amok? These are critical questions that scientists and ethicists must address as we venture further into the nano realm. What if, instead of trying to cheat death in the present, we could simply hit the pause button on life and awaken in a future where medical technology has advanced to the point where aging and disease are distant memories? This is the central idea behind cryonics, the practice of preserving human bodies at extremely low temperatures with the hope of future revival. The process involves replacing a person's blood with a cryoprotective solution to prevent ice crystal formation, which can damage cells and tissues. The body is then cooled to extremely low temperatures, typically minus 196 degrees Celsius, and stored in a specialized facility. At these temperatures, all biological processes come to a halt, essentially putting the body in a state of suspended animation. While cryonics does not guarantee revival, proponents believe that future medical advancements such as nanotechnology or advanced molecular repair will one day be able to reverse the damage caused by the cryopreservation process and restore the individual to life. Imagine waking up in the year 2250, your body restored to its youthful prime, ready to experience a world vastly different from the one you left behind. Cryonics offers a glimmer of hope for those facing terminal illnesses or seeking to extend their lifespan beyond the current limitations of biology. It's a gamble, a leap of faith that future technology will be able to deliver on its promise of revival. However, cryonics remains a highly controversial topic, with many scientists and medical professionals questioning its scientific validity and ethical implications. Would reviving a cryogenically frozen person be like flipping a switch and bringing them back to life? Or would it be a more complex process, potentially involving the restoration of memories and personality? And what kind of world would they wake up to? A world potentially vastly different from the one they left behind. These are just some of the questions that surround this fascinating and ethically complex field. Imagine a future where organ failure is no longer a death sentence, where damaged or diseased organs can be effortlessly replaced with new, lab-grown versions. This is the promise of biotechnology, a field that holds the key to unlocking a future where our bodies are no longer limited by the passage of time. Scientists are making remarkable progress in the field of regenerative medicine, using stem cells and other bioengineering techniques to grow functional organs in the lab. These lab-grown organs could then be transplanted into patients, providing a life-saving alternative to organ donation, which is often limited by long waiting lists and organ rejection. Imagine a world where you could have a new heart, liver, or lungs grown from your own cells, eliminating the risk of rejection and the need for immunosuppressant drugs. This would revolutionize healthcare, extending lifespans and improving the quality of life for millions around the world. But the implications of biotechnology extend far beyond organ transplantation. Scientists envision a future where we can use these techniques to repair damaged tissues, reverse the effects of aging on our skin and bones, and even enhance our physical and cognitive abilities. The line between therapy and enhancement could become increasingly blurred, as biotechnology empowers us to reshape our bodies in profound ways. This raises important ethical considerations about access, equity, and the potential for creating a society further divided by biological haves and have-nots. Will everyone have equal access to these life-extending technologies, or will they be reserved for the wealthy and privileged? These are questions that society must confront as we enter this brave new world of biotechnology. We've just explored 5 fascinating ways that might one day make humans immortal. From rewriting our genetic code to uploading our minds to the cloud, the possibilities are as exhilarating as they are daunting. The quest for immortality is a testament to our boundless curiosity, our relentless pursuit of pushing the boundaries of what's possible. But it also forces us to confront profound questions about the meaning of life, death, and the very essence of what it means to be human. Is immortality a blessing or a curse? Would a world without death be a utopia or a dystopia? These are questions with no easy answers, questions that each of us must grapple with as we stand on the precipice of a future where the boundaries of life and death may no longer apply.